First of all, thank you very much for the nice introduction. Thank you very much, Ms. Fatima, for inviting me for or providing me such an opportunity to speak on this very important topic. And I would also like to thank the Emirati Society of GIS and Remote Sensing for organizing such events, which are really helpful for gaining the understanding of these important topics of atmosphere, GIS, remote sensing. And today, the topic of this presentation aligns very well with the topics that the society is calling for webinars. So the topic is drones. As many of you have seen these drones in many different applications around your daily life. So the topic today is how these drones are innovating air pollution and climate research. And today, I'm going to talk about a few things. So this is the content of the presentation. So we start with a journal introduction of air pollution and climate change and how it is useful to us to understand these air pollution and climate change. And what are those traditional remote sensing or ground-based monitoring approaches to monitor this air quality and climate to better our understanding? And then how these new technologies such as drone could be useful for advancing our understanding in air quality and climate research. What are those instruments that could be used on board drones? And different successful case studies that these drones have been deployed in variety of different areas in Southeast Asia and other places for different purposes. What are the challenges and opportunities that we see while using these approaches? What are the future directions and new innovations that is coming to advance further this research technology? And finally, the conclusions, and we had for question and answers. So let's start with the basics. So this is a very nice schematic picture provided from Health Education Institute. And you could see that this in this picture, you see this is mainly for climate change, air pollution, health nexus, and this provides you the kind of segregation between primary pollutants and secondary pollutants. The primary pollutants that are released from bunch of different sources, from natural as well as man-made or anthropogenic sources. So if you look down in the middle of this picture, then you see that on the middle left panel that there are different sources that you also have seen or around your cities, that you have energy sectors, you have industrial sectors, you have transportation sectors that are contributing to the air pollutions that are primarily emitted from these sources, and that could be ranged in particulate matter, black carbon, the gases such as nitrogen dioxide, sulfur dioxide, carbon monoxide, carbon dioxide, volatile organic compounds. So in that left panel, you could see they are highlighted in different colors. This color, like in gray, represent the particles, and the white color represent the gases that are normally occurring and contributing to air pollution, and then this orange color represents to the gases that are contributing mainly to climate change. And this, when you move a slight right, then you see that agriculture also plays a big role, that that is contributing in ammonia production as well as methane production from fertilizers, from agriculture, livestock, and that's why this CH4 is written in kind of a gas that is mainly for greenhouse gas, contributing to the greenhouse gas emissions. And then also when you're moving towards further right and urban cooking and heating, you see that they also release a lot of primary particulate matter as well as volatile organic compounds, as well as ozone that is then reacting with the sunlight, and then these nitrogen dioxides, and then creating, due to photochemical reaction, the ozone is being created. And apart from that, you also see where a variety of natural sources, and such as you have also seen in areas like Middle East, where you have predominantly desert dust emissions, or these or wildfire sources you have seen in bunch of different countries. these are contributing to mainly these pollution load. And why it is important, because it is affecting human health, that apart from the climate change, it's also affecting human health, like cardiovascular, respiratory diseases, also at children and elderly at increased risk. So that's why it's so important to understand. And when you go into more detailed way and in a less in a more detailed manner of the understanding, then you see that these sources, when we are talking only about these urban sources, then you see these industries, or if you consider the places even in the Middle East like Dubai or Qatar in Doha, they have quite a lot of these ship emissions coming because of the harbor. And then you see the ship emission, this heavy duty trucks as well as this cars, they emit particulate matter, ozone, carbon monoxide, carbon dioxide. And this is again, we are talking about both the final impact of these pollutants emissions is the health, deteriorating human health like lung disease, asthma, cancer, other illness, as well as climate change, heating or warming of the earth atmosphere. Then these are specified into two different categories: aerosols, tiny particles that are suspended into gases or liquid phase, and then also the gases that we are talking about. So one is forming particulate matter, and other are the gases that are the precursor. And these gases also combine to form the newly formed particles. Then again, this is the same message that we want to convey, but in three different categories: that they affect climate, they affect air quality, they affect human health. So these are very important to understand. And they affect, when we are talking about climate effect, they affect energy budget of the planet. They create imbalance. Either they create net cooling or net warming, and both are not okay for the human or the Earth atmosphere. Then you see in the middle panel, there's a difficult situation that most of these developing countries face when there's air quality issues happening, and mostly in Delhi, India, where you see that sometimes you people face a lot of hazy atmosphere, sometimes they face smog, or we can say in terms of fog, and these are really dangerous for their health, and they are like 10 to 20 or 30 times higher than the World Health Organization recommended limits. So that's why it's so important to understand these. And one of the cases you could see very clearly from this episode in Los Angeles, United States, that you see there's a clear picture of smoke. You could see a kind of a blanket of smoke that the entire city is engulfed into. And you could see on the very top, there's a small plane going on the top. Then you see there is a boundary, then upper than that is free, and is free of all those particles. But down where most of the population is living there, and it's in direct contact with these gases, this is mainly formed from ozone, photochemistry, and so much important to eradicate, to minimize these. And for that, you need to monitor these. You need to understand, like, where are the sources, source apportionment, what are these from, what are the sources that are contributing to. And that's why we see that there, from like last century or decades, there are more and more of these traditional remote sensing or ground based instruments that are available to monitor the real time air quality or climate change kind of understanding. So we see that in this slide, you see on the right panel, when you see, then you see this is the traditional approach as well as modern approach combined in this picture. But you see, most of you are aware about this remote sensing tools like satellite-based remote sensors, as well as ground-based LiDARs, or max DOAS technology, or aerosol spectrometers. So these, apart from these instruments, so these are the main instrument that contribute to the ground-based measurements and the satellite-based measurement. So both combined can be termed as traditional approach. But now we are also seen a kind of modern approach, that there could be mobile sources, like these sensors or instruments can be placed on bicycles, on moving van, on backpacks, and then you get more spatial information of this air pollution emissions. So if you consider that when there's a kind of stationary station placed in some of their your own institute. And if you want to monitor the air quality near Dubai Mall or Burj Khalifa, then what do you do? So basically, you don't have the emission sources information over there. So these mobile platforms are really helpful. You take these small compact instruments and then monitor those. And that's how these drones are also really handy when you really want to get information of some of the gas leaks or some of the hard to go area or inaccessible areas and which is hazardous for human to reach there. So then we send these drones over there, and then these could provide us real-time information of the gas concentration or particle concentration. And then that's why today we are going to talk mainly about the drone-based measurements and how they are improving or innovating our air quality and climate research. But before moving further, talk a little bit more about let's talk a little bit more about this measurement techniques that is ground-based remote sensing. And you could see that there are different three of the main spectroscopy techniques that are mentioned in this slide. We go one by one. So one is, but not much in detail, but we will talk about the major principle of working. So this dial is the one of the mainly used is differential absorption laser. It stands for that. And you could see in the left panel on the top that there are three markings in this picture, 1, 2, and 3. And the one is where the pulse laser is, and this laser pulses actually carrying both on and off resonance photons, and that are being emitted from here. And then these pulses strike the greenhouse gases at each target, and some photons are backscattered. And then in the three, when there is a receiver, the backscattered photons are detected and counted at the receiver, and that the return time delay indicates the distance that they measured, and the ratio of on and off of the resonance that you have seen in the black wave pulse, its own resonance, and this kind of yellow or orange, it's off resonance. And then the ratio of this reveals the concentration of these greenhouse gases that are being measured from this absorption technologies. On the other hand, this max DOAS is differential optical absorption spectroscopy multi-angle. And then multi-angle again refers to this telescope you see in this picture, and on the left side you see the solar zenith angle. So this telescope, so it so these rays it strike at the sunrise, it strike at different elevation angles, and from different elevation angle you can calculate the trace gases concentration from this max DOAS or differential optical absorption spectroscopy. Again, this based on the difference and the differential of the optical signal that you receive via absorption. And then you also have tunable laser differential absorption spectroscopy. So these are some of these main spectroscopy techniques that are being used so far as a ground-based, but there are some certain challenges with these traditional monitoring methods. When we are talking about these ground-based measurements, specifically aerosol spectrometers, LiDARs, MaxDOAS, TDLAS, all those technology that we mentioned in the previous slide. What are the advantages? So we have high accuracy, accurate data. We have high detailed aerosol gases, physical, chemical data that is available. Gases concentration at high resolution is available. But what are the main challenges? So main challenges is they only provide data at specific location, and if you really want to get more special idea from the city-wide, or if you are really want to get some point bit sources from some methane gas plant or some other places, then you miss those information. And this also require high maintenance cost, require frequent calibration, maintenance, and this also requires skilled personnel. Also, this, as I already mentioned, there's uneven distribution. Most of the stations are in one or two places of urban areas, and then fewer in remote regions. And then you really want to get insight of these hotspots, you are unable to do so. Then there come another technique that provides some rescue from these challenges, and then satellite measurement provide you global coverage. They provide you more comprehensive view of atmospheric conditions. They have long-term data records, but what are the challenges in that? So they also have low temporal resolution. They pass the same location only once per few days. There are data calibration issues. You require more corrections due to atmospheric interference and sensor degradation. There are also difficulty in vertical differentiation. It's really hard to distinguish pollutants at different heights, and also cloud cover and aerosol interference. So once you have more cloud cover, then it can obscure measurements and this could lead to inaccuracies. Within the lower boundary layer where most of this air pollution and gases release or chemistries that is happening. So from what should we do in order to complement these approaches or to fill some of those challenges that we have from these techniques? So what we do, we use drones in the lower panel in the lower range of this boundary layer, and we see in this slide that how these drones are really useful in transforming air pollution and climate research. So this air quality monitoring, when we are talking about, so these drones usually equipped with a lot of different sensors to detect the pollutants such as carbon monoxide, gases, particulate matter, aerosol properties, and they can measure these air qualities at different altitudes, locations, even in the hazardous zones, help us to track pollution in sources, especially that I already mentioned some of the industrial zones where there's a gas leak and it's hard to access, and also provide real-time data to improve our air quality models as well as the regulations, also support wildfire smoke monitoring as well as impact on air quality. When we are talking about the climate research, they are much more helpful. They provide us the data that that is really useful to understand the greenhouse gases emissions from both the natural and industrial sources. They can also monitor glacier melt rate, rising sea level, help us study weather patterns, storms. So a lot of people in United States, they are using these storm chasing drones, and because of the high storms areas they experience and extreme climate events. They can also track deforestation, land use cases, and they can also assist in studying biodiversity shift. And we will see in coming slides some of the case studies that shows us these use cases of drones in both the research zone or areas. So before moving further, let's mainly focus on drones. And drones are can be classified based on their different rotors as well as wings. So you could say there are different pictures mentioned here from A to G. And you see that in the picture A, you see there are four rotors, and then four rotor corresponds to and four rotor can be termed as a quadcopter. Then you have six rotors known as hexacopter. You see in figure D, there are eight rotors and it's for mainly eight octocopter. And then you see there could be fixed wing where you only have wings and that are used from fuselage. And you see in the G, there are also people using in small helicopter type drones that could be really handy for certain application. And that this kind of drones specification or choosing of these drones are dependent on your research topic or research question that you want to address. If you really want to have the impression of vertical identification of those gas leaks in plant, then you only need these hexcopter or quadcopters, right? Then you install your instruments on board it. But when you really want to have a bigger idea or to track these or chase the storms or to see the wildfire emission from the wildfire from large areas spread, then you don't rely on these drones. Then you rely on fixed wing that are bigger. Then they also track in horizontal direction and in addition to the vertical direction, and that's how these are being used. Then we talked about these drones. There are different specifications, but what are those instruments that could be used on board those? So there are some miniature or portable or small compact aerosol and gases instruments available nowadays that companies produce for drone applications. One of the main is for black carbon identification. And most of you know that black carbon is one of the main source for also climate research, warming of air pollute, earth surface, also in haze in air quality degradation, this black carbon plays an important role, and it's really important to understand the vertical profile of black carbon to provide this information into model to reduce the uncertainties. And that's how you see in this picture. This is a small compact instrument produced by Maggie Scientific Company in the United States. The name is microethylometer AE51. It works on one wavelength, 880 nanometer. There's a light source, and then it produces this light, and then it touches the filter spot. You see that this is in the down figure. There's a small filter and there's a small dot, and this is the dot 3 mm with the BC spot, where it is hitting the light source and then interacting with the particle, and then it absorbs the light energy. This is being produced and then finally shown as an output in mass concentration. And these are some equations and what are the parameters that you need to put in order to get this black carbon mass concentration. Then you also see particle size spectrometer. You also need to understand the particle size ranges. And this is one of the compact instrument. In the left panel, you see this for the particle size in small size ranges. That is really important to understand the formation of haze as well as the rise of or the growth of the particles that are at release in the atmosphere from primary and secondary emissions. On the right panel, you see there's a Lycor company based, this is a Lycor based CO2 analyzer or also H2O gas analyzer. So you see this is also based on similar absorption based kind of technique, and you get this concentration. But these are really handy and small and compact instruments that you can place on board drone to get the vertical profile. Nowadays there are also shift on low cost sensors. So this is the sensor that I'm showing for particulate matter, but currently this sensor also comes with gases information, so you can have all this information ready in real time with low cost. Is really low cost, so within like few hundreds of dollars. So then you really be able to get more information of spatial, temporal, and vertical dimension, the 3D structure of the air pollutant information in cities. Then we talked about a lot about drone and the instruments, but let's talk about the effective sampling protocol that one need to follow, because it's not simple that you directly place these instruments and you get the data, because there are many factors that one needs to consider in order to have effective sampling. Reliable data come from these drone-based monitoring. One of the main approach is doing intercomparison experiment. It's a very nice picture shown here. You could see that this is a drone flying, carrying the loco sensor, and then this is flying very near or close to this referenced monitoring station, and that provide you that how much impact these rotors that are spinning can create in because the pollutants um, which are being taken for this these as an inlet of these particulate sensors, those can be really have issues when there are large circulations or from the surroundings of these rotors. So that's how it's so important to understand that one need to follow this protocol before going for actual field campaign and getting the results. And most of the people they miss it, but this is in this recent publication it's shown it's highly recommended. Another issue you could see from this figure is humidity. So this humidity, this water moisture content in the atmosphere, it's present everywhere. What it does with this optical spectrometry or this optical spectrometers, they tend to overestimate uh, these particle concentration or other properties, because they somehow mis represent those particles that are being collected from this instrument because of those moisture content. So one need to dry this moisture content before sending those particles inside the instrument for further processing. And that's how you see in the left panel top that there's a dryer mentioned specifically, and also there is a long tube inlet to protect from rotors. And this is a very nice setup to explain that this is the main steps that one need to follow. You also need to take care of minimization of humidity impacts using dryer, and you also need to take consideration this rotor impacts. And then you see again they are flying on the right panel, this drone setup. with this kind of reference monitoring station. So they are following complete protocol in this recent study published in 2024. Another case is this another study from Taiwan. They also use this sampling tube, a GPS. One main thing you notice here is they are not using any humidity to minimize humidity. This is why, because they are measuring in summertime and they are below 40% of humidity, and that case you can avoid, but you still need to provide sampling tube it, way beyond to that rotors in order to minimize that rotor impact. Then let's talk quickly about the successful drone deployments for air pollution monitoring in the case studies. And you see, this is the first case study from China in 2020. They measure different pollutants, and you again see that there's a these small compact instruments are placed at the bottom, but then they are connected with the long cable that is coming or inlet that is going up in order to avoid the rotor impact. So they're also providing the complete strategy of monitoring air pollution using drones. And then you could see on the right panel the height is mentioned on the y-axis, PM 2.5 and BC on the x-axis, and then you see particulate matter variation at BC variation, and you see in the within the 100 meter there are fluctuations, and these fluctuation you see there's a rise in black carbon contributing to haze. If you do not have this information, you miss completely when relying on traditional or satellite based instruments, and that's how it's so important to get the columnar picture, and these complementary approaches are really useful. Another study is from India where they used to study different emissions from different areas, dump yard, residential areas, industrial areas, and they monitor this using drones. They used different methods of like using machine learning based technologies, bigated output prediction system, and then based on this, because you know that you can't do these drone activities on every single day, but when you have certain reliable data, then you could feed into these models, and then you can also predict it for those days when you are not doing this drone activity. So this is so handy that new techniques can be used together in order to get more outputs. Another study is from China, and this again shows you see this is a POM and MA200. These are instruments to measure. MA200 is instrument to measure black carbon is similar to what I've shown, but this works on three different wavelengths. So you also get information about brown carbon that absorb the light in the lower wavelengths, the 340 nanometer or something. And then you see POM for ozone monitoring. And that's how you see in the area of Shenzhen in China. Then morning and afternoon flights in the right panel, you see the flights that height with height for 1 kilometer. And this is black carbon mass concentration. You see ozone mass concentration. And this is another optical property absorption, angstrom absorption exponent. But you only focus on the left and more right panel, the EBC and ozone. Then you see that there are different profiles, and within the lower range you again see there's a rise in concentration, and there are shift in concentration that you need to study in order to get more understanding. This is our study that we did in India, in Delhi, in a polluted environment. We wanted to get more information about vertical, and we also try to attach the sampling inlet. We also try to have all those dryers in order to minimize the humidity, because the humidity were in more 80s or percentage. And then you see those results. These are the drone that are flying, and you see on the backdrop again it's kind of similar to what you have seen in Los Angeles. There's a kind of pollutant stack there within the limit, and then drone is flying in that and getting the information. And you see that for different mornings, hazy, non-hazy mornings, we get the impression of the vertical profile for the first time, because within this column there was no information available. And you see that these are contributing to haze. If you see the case of 18th of March and 20th of March, you see more of the pollutants when compared to ground at higher altitude. And if you consider the case of 23rd March, which is the day after rain, and then has all the most of the pollutants got washed out, and you have left less mass concentration of pollutant, and you see that it's a vertical straight line showing no such changes. So it's so important to understand these dynamics of vertical changes in air pollutants to get more understanding of age. Let's talk more about the drones for climate research, because we talked a bit about the successful case studies in air pollution research. Drones could be really handy in disaster response. You see, this is a nice image from DRI, Desert Research Institute. They are doing some research in wildfire that are common in United States area. And then these are when you are doing for the early response or warning, these can also be handy. On the other side, when this is gone, you need to understand the smoke characteristics, the profiles of smoke, the gases concentration, other information for detailed analysis. Then this can also be really handy. Then you see this kind of drones are also designed to get information about the greenhouse gases emissions, is carbon dioxide and methane. And you see from this recent study from Bollock et al., and they provided a nice setup, and they also use this in the left panel. If you see in the bottom, they have used this Lycor 850. This is the instrument that I've shown you in previous slide that could be useful for CO2 based monitoring. And you can also see in the right panel all the kind of setup that they use in order to get the information about CO2. But they also place some methane instruments, and then to get more information about these from natural sources. But these drones can also be placed in the area when there is a methane leak from oil wells and other industrial areas. Then these drones can provide you information of those real-time information of greenhouse gases, alerts. This could send alerts to the public living in the nearby areas, and these are so handy in all these applications. Again, this is the same kind of setup that I was showing in the previous, but this is from some other company that manufacture this differential absorption spectrometer in this diode tunable diode laser absorption spectroscopy methodology. And these are the instrument that you can purchase directly from this company. You can place it on board drone, and you fly it, and you get the information real time analysis of methane. These are so important and provide you more information about the changes or the climate kind of climate research. Let's talk about more on biodiversity. So this is a quite a busy slide, but let's go through one by one, step by step. So you see in this picture, we start from the preparation. So this is an overview of drone-based eDNA. So this is kind of a DNA that we have in our body, that we see the DNA from other sources in our biodiversity. And this is a strategy that one of the study in Switzerland they applied. So what they did, so they prepare the drone with the probe, and then this is the before the takeoff. You see in the two, and then the drone flies above the canopy to reach the sampling site. It's hovering over there, and it lowers the probe into the canopy. It takes the swab against the vegetation to collect the eDNA. It's like the same when there was a COVID and someone was taking a swab to get your information about your DNAs or something like that. It takes the same kind of setup. And then after taking the swab, the drone returns and lands, and then the probe is removed. And this is the first part, collection, and then the second part, analysis. And then analysis could be followed, as you see from the ground-based approach. They extract the DNA, they amplify the eDNA, they do the sequencing, and then they do the bioinformatic pipeline. And then after that, more assignment and results are being prepared based on the data that is collected. But the main part is the data collection, up to data collection in the up to point 5, that how much effective these drones are in these areas, also to conserve or preserve our biodiversity, to get more information about this the kind of eDNA from different species. Then this is a kind of extension from the same study, that how they did it. So you could see that E probe surface sampling. So A, B, and C represent eDNA collection, probe design, and the drone sampling system. And D is when it is hovering, and E is when it's taking the swab. So when we go one by one, so A means is eDNA collection schematic for descent, like going down, or ascent, going up of the probe, with the transfer of those eDNA particle from vegetation through touch when they are touching. The probe is designed to collect the material stiffener and with the probe mount. And then the complete drone sampling solution, which is available with the winch, that third probe in the down of the drone that you could see. And then when this complete instrument or sampling system is set up, then they are placing it in the real forest. This was taken in Amazon forest. And this is a drone hovering and deploying the drone in the canopy. And then these are images that are taking when there is interaction at different time of the descent. That is 1 second, 3 second, 14 second, and 15 second, something like that. So this kind of experiment can also be useful in getting the information of the eDNA in air of those microorganisms, eDNA that are lost or that are about to lose, then how to preserve them. All those information is really required. So these drones are really handy for that research. This is a section of climate research. So after going through all those successful case studies in both the dimensions of air quality as well as climate research, let's talk a bit more about future trends and innovations. So we talk about artificial intelligence and machine learning in drone-based monitoring. So there are a lot of significance of these artificial intelligence and drone technologies. So they are divided into certain different steps. So what you could do, you could also do predictive maintenance. You could anticipate in the maintenance need and unexpected losses. You reduce the operational cost through proactive maintenance. You get the situational awareness, provide real-time data on environmental conditions. It improves the decision making through advanced sensing. Also, it provides you autonomy. You can also run fully autonomous drones of operations without actual use of humans. And they can also increase operational efficiency and reduce error that could be caused from humans. Then they can also facilitate real-time processing and data analysis. Like these days, you have explainable machine learning or AIs or generative large language models that provides you more actionable insights and improve decision making. So this is the significance of artificial intelligence in drone technology. And one of the main concept is swarm technology. So not only one single drone, but how these AI assisted drones, multiple drones could be used in a single area to monitor air quality or to track wildfires or for climate research. One of the very nice schematic provided from this recent study in Motlag, they provided for air quality based swarm technology. And you could see that different sources of air pollution are being tracked from these different bunch of drones you see hovering over there on the cities. One is tracking the air pollutant from vehicles, ship emissions, tracking from residential areas, industrial areas, and then there is a one set of center data storage where all the data is being processed using 5G, 6G cell network. The real-time data is provided to the cloud center. And then this is really important information for the policymaker in order to provide or governmental body in order to reduce or minimize the emission from those areas that are coming and the information that was not available to them beforehand. But there are certain challenges and also opportunities in this drone-based monitoring. Let's dive into that. Also, this recent publication from Motlag represent those challenges as well as opportunities. You see that the challenges are the energy consumption. Most of you are often wondered that these are flying for 15, 20, 30 minutes. What will we will do with this kind of information? Still, we are getting more insight as you see from previous slides that they are still handy. And as days progress, there are progresses in batteries. And you see that these batteries are upgraded and you get more endurance time later on. And these drone technologies is also getting more updated. So we can sort these things out, but still there are certain challenges considering this energy consumptions. Still the networking and communication only based on GPS. Sometimes you have crashes happening. There are securities issue. There are still issues of obstacle detection and avoidance. But nowadays there are drone companies that are coming to avoid these issues that are already there. Then there are regulatory and societal implication. Most of these drones are banned in certain places in some countries. They are not allowed. But you see, there's when there is a new technology, there is a resistance in initial days. But when people see the the use or application of these technologies, they will adopt to it, right? And then they are really handy. The opportunity is massive. Air pollution sensing, they provide you the source detection, hotspot areas where there's the most emerging source emission are there, diversity or accuracy of the sensor. You can attach many of these sensors, and these are some of the opportunities that drone can provide you. So for our presentation, hope few things are clear to everybody, that how these drones are useful in place of these traditional approaches, or these actually not replace, they will not replace these approaches, but I always say that these technologies provide a complementary approach to traditional air pollution monitoring. We still need all those regulatory satellite data, but these can provide you those at the information in those areas. They are hard to get the information. These are really extremely effective in early detection of wildfires and climate research. And the again that I showed, methane detection, climate research, biodiversity conservation research. These drones are found very much suitable to, and you could see easily from these biodiversity that in Amazon forest they're hard to get by the information. They can go easily. If you follow the effective sampling protocol, obviously you'll get more robust results. And then we are talking about the future innovations such as AI, swarm technologies, quantum sensor that I did not mention here because that could lead into certain different direction, can also provide unprecedented insight on air pollution and climate research. Thank you very much for listening to this presentation content. And if you have any question or discussions, let's talk about here.